everybody. Welcome to Rocket Lasso Live, episode 11. How is everyone doing? Happy Wednesday. Here we are, ready to do some Cinema 4D. Let's see what we create today. We've had a couple good episodes. I think last week we spent the entire time on a single episode, which is not something we do very often. I just remembered I didn't prep my folder. It's always a little bit of a thing. Copy. Episode 11 already. Time flies. Scene files. Delete. While I'm prepping the folder, do everybody get those questions together. You can write them out, or if you got a link, you can post them on YouTube's chat. I like links. If you are sending a link, make sure you link. If it's a video, I need the time code so I know which specific effect you're interested in, and I need to see the artist or the studio who put it together so we can give proper credit. Episode 10, drag in episode 11. Check that. Delete that. Cool. Okay, that's ready to go. Audio is probably low because I'm a little bit further away from my microphone. Pull that up higher. How's that? Is that better? Everything else should be standard, so, and I did not change anything. Links, or questions. If nobody has any links, if nobody has any questions, then we don't have a live stream. Let's see. Any news on my end? Let's see. Beta's chugging along. I'm really excited about the next capsule that we're working on for Maxon. I think it's gonna be a really good one. That's getting ready to go into its own little beta. So yeah, can't talk about it, unfortunately. I gotta see if at some point they let me do sneak previews of those, but then the shipping date's always a little off. Maxon tends not to do too much in the way of teasers, so that's pretty. It's not something we're gonna probably get permission to do, but it would be cool if we did. Let's see. Pre-question. Scott's asking a pre-question. Do we have any interest in investigating some specifics of creating an afterburner effect for a jet or rocket engine? How's that a pre-question? Afterburner jet or jet engine or rocket engine. The worry with that would be that, I mean, in old physical and standard, we would have done that type of thing like using visible lights. And I'm just not terribly familiar with the volumetric lights in Redshift, which obviously would make everything look better. So that'd be tricky. Justin on YouTube is asking about maybe building an LED video wall. You know, what's funny is like, well, LED walls have gotten really detailed, and the resolutions have been crazy. But way back before Rocket Lasso, before Grayscale Gorilla, I worked at a company that did, I guess you might say, like corporate theater, where it's like stage productions for different companies, and all the time, like there's different types of screens, and there would be LED walls, and the LEDs were like, you know, pretty far apart and whatnot. But I remember even, you know, we're talking like many years ago, I built an entire rig when MoGraph was pretty new that all did like an LED wall effect. I could put any picture in and that would work. So that might be kind of fun to recreate. You know what? I'm going to, I'll share the screen in a second, but right now I'm just going to do a generic image search on LED wall. See if I can find some nice looking results, because there's one level where the resolutions have gotten so kind of crazy that I'll just swap to the screen. On one level, the LED walls have gotten so crazy that here, LED walls have gotten so crazy that it's almost like, well, what's even the point of it being an LED wall? It's just like, oh, just apply a luminance material on there. Where the thing I'm talking about, it would have had a very low resolution. Obviously, that's digital. Those are the volumetric things. So there's a level where, yeah, so this is the type of thing we're talking about. Like when you get really up close, where in theory it's kind of like, oh, every single one of these little pixels becomes its own dot of color. And then obviously, like, you got all the mechanics of like doing like all the connections and all this background, but like you don't need any of that. I mean, some of the LED walls used to have like enough space in between them and whatnot that you could kind of put stuff behind it and kind of see through it. So if you had a more specific example, we might be able to tackle that more specifically. But for now, I'm going to interpret the question as doing something kind of like this. Now, even if I click that, you're going to see that it does feel like every one of these, um, like there's a little bit of extra color in each one. I wouldn't be worried about that. I would just be trying to make them like take on the pixel color of what would be behind it. So yeah, looking at this type of thing, like doing this and being able to feed any kind of image through it is what I'm aiming for. If somebody has more specific, something more specific than that, along the lines of an LED wall, please let me know. But I'm pretty sure we can do that pretty straightforward. Pretty straightforwardly. Let's go over to the laptop. And yeah, let's see. I mean, we can do a lot of stuff in a pretty straightforward way if we're kind of mimicking that image that we were just looking at. And these LEDs are probably like pretty dang tiny. So if we're gonna make a figure, we're gonna want some stuff to be really small. So we're gonna go real tiny. We could do some very specific measurements, but we're just gonna eyeball it. So that's gonna be like the little tube, and I'm going to make a single disc shape. And this is going to be our actual LED. Shrink that down so it's in the tube. And we'll leave it just back in it a little bit. We're intentionally making this two different objects. We'll actually use that as a feature for ourselves. Actually, I will flip these to be Z forward and then reset my transform. And I'm not sure if we want that forward or backward. But anyway, let's go and drop in those into a null and make a cloner. And the clone's already set to a grid. We set our distance, so we'll say per step, and I mean, probably not too far apart. For now, let's say like 4 centimeters apart. So let's say 3 by 3 by 1. Yeah, and those are facing this orientation. It looks like it is flipped around. Let's keep that in mind where we might be looking at the back of the dot, but we'll keep that in mind. And I'm going to, for now, intentionally leave it at a low resolution. And I'm pretty sure we can do a multi-instance on here. So why don't we activate that right away? But let's just keep in mind that indeed it is a multi-instance. So, and maybe we'll do a little Xpresso here to build a rig so you can kind of see the type of thing I would have had like back in the day. So for now, let's say that's like 300 by 200. Actually, that's huge. So we'll say 100 by 200. So big old LED backer for the character. Now, let's set this up a little bit more specifically. Well, we're going to want to be able to feed in some sort of image here. Do I have a picture of some sort? Let's see. Did we do any renders? Do we have any images? I mean, it would be nicer if we had an image. 1 second. Let me just search computer for images. We must have rendered something nice at some point. But of course, this computer doesn't have all the stuff on it. Tree trunk break. That's a still. Where's that animation? Oh, it is an animation. It's not the best framing, but yeah, I'm going to steal the tree trunk from last time. Boop. So let's copy, go into the new file, go into our scene files. We'll make a new folder called TEX. Inside that folder, I'm going to paste the little render that we had of the tree trunk. So that's in there now. If I hit play, you can see that it's something fancy, and I'll make sure to offset the image so we're kind of looking at this bottom part, but at least it's kind of giving us something that can move. We probably made some nicer particle stuff at some point, but immediately, if we're going to use that material, let's save this. So save into my new folder. LED, actually 1A, LED wall. Save. Cool. Now we can actually link to that pretty easily. So, I'm trying to think of like what we should do on what step here, because I want to kind of follow where people are interested. So if there's a kind of different vibe, but it'd be kind of fun to make a whole little rig out of this, is what I'm thinking. So, I guess where would we do it? I mean, I would constantly modify my rigs, but let's just make a material for now. Although we can't reference a redshift material, so we have to go. I will make a standard material. So I just go standard and then make it that way. I just find that faster if I'm already in the menu. So yeah, standard material, and then we can load whatever we want in here. So I'm going to say, okay, give me the material we just put in there, video. That should automatically, if you go under animation, you can see it. Yep, it's already got the animation. I can set that to loop as well. And yeah, that's all I really care about on that. So that is now something that we can apply kind of mechanically. So if I were to put this onto, I don't think I want to put it on my cloner, because then that's implying that's the material that's getting applied through there. So what I might do, and we might use this for swapping purposes later, I'll set this to Z+, also set it to 0 by, or 1 by 1, a height of 100, a width of 200. Oh yeah, and then we also have to say that there's 4 centimeters per, so I say times 4, and then say times 4. And now I've kind of got that proper layout. And you know what, for now, I'll just leave everything centered and we'll offset them later. So now I've got this plane and I want that material, I want this material to be on the plane instead. And now you can see that we've indeed got it. It's kind of flipped upside down. I guess we could flip it. Yeah, I'm gonna flip that around. And the reason I'm doing this is now I could do something like a flat projection and go to the scaling. And now I could scale this to whatever size I want. And I have the capability to make it extra big and offset it like that, so it fills up the whole screen. And I'm doing that because we can now use that as the projection to reference. So maybe even for now, visibly, I'll hide the plane and go back to our cloner. In the cloner, I will say I want I think we want a plane effector. And it is not going to affect the position, but it is going to affect the color. And the color is going to be driven by a field, and the field is going to be thanks to a shader field. So we make a shader field, say that you are outputting color, not the kind of value. And in the color, I don't want to reference a custom shader. Instead, I want to look at the color channel, and the color channel has to be in an old style of material. So we will now link, not link to the material, but we link to the tag. And what's cool about that is it takes on that local projection. And having done that, where we've linked the material on this plane, I can now zoom up and you can see that every single one of these has gotten that material applied, and it's getting applied as the entire object. So, you see the entire thing has taken on the color of that pixel. Now, that is the cloner taking on those colors, but I'm pretty sure if I apply a material, if I apply this material to just the tube, you can see that the tube is now not getting colorized via the cloner. So we'll just call this one, what would you call, kind of like that dark kind of black metal. I mean, just very, very dull, black, kind of shiny. We'll even kind of make it metallic. Yeah, something like that. So that's going to be that. And then let's call that metal. It's fine. Kind of a, make another material. We'll call this one the LEDs. And apply that to, we could probably put on the disk, but I'm going to put it in the overall cloner. And on the overall cloner, let's double click and make a color user data. Output that into not the color. I don't want color. I guess we can have reflection. They'll reflect off of there if they're shiny, which maybe they are. But mostly we just want this emission, and I'm going to make it pretty bright. We probably end up making it even brighter later. Holding down Command or Control, click on your little output dot here, click on that, and then I see it gets exposed on my material. And I will link that to the color, and clicking on the color user data, let's go to the presets, and you can either say MoGraph color, but you can also say object display color. Is there a difference between, maybe nope. I thought maybe one would display it properly in the viewport, but it doesn't. I have to say I tend to just do display color because that means it'll work if you customize the color of the object or if MoGraph changed it. And because essentially MoGraph is just changing the display color. So kind of a little tidbit for you there. Now, it's not showing up directly. Is that because it's a multi-instance? No, I think it's just going to show up at render time, which, personally, it's completely fine with me. Um, Potentially we could move the material. Maybe we could move the material in such a way that it wasn't there, because it was maybe kind of nice to see it previewed like that. But honestly, I'm not seeing much of it, because we're not going to see much of effect at all until we get a glow going on there. So let's make this stuff a little bit more fun. Let's make a floor. Like I said, for now, I want to build everything at 0 because we're building a rig. So I'll just scoot this down. And I'll make another material. I'll call this Marlow. Marlow is a type of material that's often used on, I think it was called Marlow, type of material you use on stages, kind of like a shiny floor. So it'd be pretty dark and pretty blurry. But it would be a little bit shiny. It gives you like a nice reflection, which will look nice on an LED. And yeah, we'll just move our figure down there. Might as well have some reference for scale. Okay, and then I don't know if we need a backdrop per se. Let's make sure the plane, that's the floor. And this is going to be the, I'm just going to call it the TV, which we might pop in. Okay, so, and then, because we're here, let's make ourselves an HDR. I'm going to give it something that's got the vibe, not too bright. Yeah, that's fine. Something a little bit studio-like. Yeah, that's fine. Okay, Redshift, render view, go. Cool. Yeah, look at that. So immediately working pretty well. Like you can see that, like, you can see through them, but you get a really good vibe for the image. So there is an LED-like effect happening immediately. And if you were to put the figure behind there, you can still see him. And I think that obviously there had to be those interconnections, but for the most part, the real ones, certain types of LED walls, you can kind of see it through it like this, where if you turn off the LED, you can kind of see behind it. Maybe in a slightly smoky type way. But let's move the figure back again. And then here's what I really want to do is we can start brightening up that LED as much as we want to. So back to our, I'll call this one the reference, back to our LEDs. And scroll down and let's make it 15 times brighter. And now you see it's getting a little bit maybe blown out, but it's super bright. And then let's try giving it a little bit of bloom. So let's add some Redshift post effects, go to bloom, activate, and I don't think we'll see anything right away, but as we lower this threshold lower than 15, I thought we'd see a little something there. But yeah, okay. Well, I'm still going lower and lower. Maybe the angle we're at, but you see we start getting this kind of blown out glow, which is pretty much what I want it to be. Let's make sure this is fully going. Yep. Spin around. Yeah, so I did let them sink back in a little bit, but I don't think that really changes much. And we get this nice bright glow. We could we could brighten up those materials. I didn't. It's a little weird to me that we had to. Maybe it's just because they're so tiny that threshold mattered. Now, there's a lot more things I want to do with this, and I don't want to spend a ton of time on it. So I just want to do a little bit of Xpresso because I still get Xpresso questions, not infrequently. And the problem with Xpresso and the problem with teaching Xpresso, even though I have made a couple of Xpresso tutorials, is it would be like saying, I mean, in a way, it's like saying, teach me 3D. It's like, well, yeah, but you need to know about modeling, and there's a bunch of stuff to know about modeling, and you need to know about lighting, and there's a bunch of things to learn about lighting. So with Xpresso, everybody's going to have its own unique case. Well, it almost goes to like, imagine you watch a tutorial and there wasn't a tutorial on modeling like a specific mug, and there wasn't a tutorial on modeling like a Lamborghini. Imagine there's just a tutorial called like 3D, and it's just like, oh yeah, like this tutorial's taught you everything. Like metaphorically, that's very similar to Xpresso, where every single person wants to make something different. If everybody wants to make something different, then it's kind of like, well, you have to teach the tools of Xpresso, generally speaking, and people need to apply it to their specific use case, because you couldn't make a tutorial on every specific use case. So what the use case is that I want to do right now is going to be building up just a couple controls so we can control the size of the LED screen, have it pivot from the ground, and probably control the density of the LEDs. I'm not sure if we can control, actually, I'm pretty sure we can't control the brightness of the material. Like, I don't think we can control the LEDs brightness inside of Xpresso. I think it breaks the link to the material. Although, somebody just popped in my head, I wonder if this does work. If I go into the plane effector, we've got this color. I'm going to say unclamp it. And if we made this output to be an even brighter value, will it get brighter? So I'm going to say, actually, you're outputting, I'll just go overboard and say 10 times brighter. Does that filter through? I don't think it did. I'm going to say the strength is 1,000% as well. No, it does not seem like that has any effect. Then one last thought was like, okay, let me try and do the same thing with this. And now it's just bright white. So if we were to do something like green, that's a value of 100%. I can increase the value. Oh, that's interesting. That's very interesting. If we make the value very dim, it's not really changing that color. I thought that maybe making this material itself brighter. I think not in red. Yeah, that doesn't really have any effect whatsoever. Well, at least it's definitive. I thought that might be a neat way of over brightening it, but it doesn't seem like we can. And now, and keep in mind, I turned off clamping, so it should be able to have gone higher. And a lot of these are just actually a lot of these modifications probably don't affect the color. They are only going to affect the they are not going to affect the color at all. They only affect the value. Give me one sec. I haven't saved this. All right, I did save it, but give me 1 second. Jump there and go here and go there and bump. And open again. All right, sorry, just had to tweak something there. Doop. Dean, that's what I was just getting rid of, so don't no follow-ups on that. Okay, are we back on laptop? Okay, cool. Boop, boop, boop. Okay, and we're back. So, okay, back to the LED. So I want to make some controls. Where is the master control I want to have here? I'm trying to think of the way I used to do it. Because you could just put it on a null. This is silly. This is very silly. But I think I might have made a lot of my tools with an empty instance. And there might be better ways of doing this now. But if you make an instance and then I say clear it out, you get kind of the red icon. But what I like about this is essentially this is a null that does nothing, but it has a checkbox. And that checkbox enables me to turn off a hierarchy. So what I'm going to do is put everything involved in our lovely new LED. And let's just call this an LED wall. And on this instance, we are going to add on a programming tag, Xpresso. And we are going to add in some user data. User data is on there. Oh yeah, and so let me explain what I was talking about. Is like, first of all, Cinema is a lot faster than it used to be. But if you have a bunch of objects that are like parametric, you see that here it's like parametric, like everything in here is there. So I could hide these, but even if I have this collapsed, if I hold down Control or Command as I click this checkbox, it turns off the entire hierarchy. So as long as you're always turning everything off or everything on, that's a really quick way of kind of like just disable that for a split second. So yeah, quick, like kind of one click, like hide it, bring it back again. So if I need to look behind it, move it somewhere else, like find it. That's just an old trick I used to like doing. So we're going to try and keep the controls relatively straightforward. So let's add in a data. And yeah, let's make a real value unclamped on the maximum value. Step of 1. This will just be our width. Step default value. We'll say the default is 200 wide. And then we will copy that. I think I just right click, copy and paste. And I'm doing that because it already has a bunch of settings I like. Height, and its default value for height will be 100. And then what's another setting? I'm going to add in a new data. I'm going to call this I'm going to call it distance or density. And we're going to give this another real value, no maximum. Yes, is actually, we might want to actually give ourselves a bit of a minimum. So I'm going to put like 0.1 so I can't accidentally put too tiny of a number, and say the default value is 4. And this is going to be the density of the LEDs. And let's see what else. Oh, let's make another one. And I'm going to say, do we go super crazy on this? I'm going to say, actually, let's just say it's a bool. So I'm going to say this is the LED wall and change the data type to a Boolean. And the default value will be true. And I'll move that to the top. Oop. Actually, it doesn't want me to move it to the very top, which is interesting. Oh, something's being a little buggy there. What is it? What is going on? Why is it not... do you see how it's not letting me move it as a neighbor? It's only letting me drop it as a hierarchy, and it's not letting me get out of it. What? That's weird. I mean, Xpresso hasn't really changed in a long while. Okay. What's going on? Yeah, those ones that just got made as sub objects. Weird. Oh, it was like, you see, it looked like that user data group was missing, which is very strange. Anyway, seems to be working now. So width, height, density, LED wall will be up at the top. I tend to stack my parameters to be like either the most important parameter or the ones you're going to use most often. You can't always do that, but generally speaking, that's what I like to do. I say, okay, now you actually see that we get our controls. Now, let's keep things relatively straightforward. Actually, my control click to turn off might get invalidated by something I'm about to do here. But let's open up our Xpresso, and we need our LED wall. And I can click and drag in each parameter here, which is a little bit faster than doing it manually. And then there are the things that we actually want to control. So I'm going to want to control the TV. I'm going to want to be able to control the cloner. And potentially I want to be able to control these two objects turning on and off just so they're not in the way. So I will also drag those in. So I'm pretty sure the projection will still work. So let's do this as simple as possible, where I just want the enable condition for each of these. So I'm going to say enable, basic, enable, input, basic, enable. So now we got the LED wall. So it's like, if that is true, what do I want to correlate to it? Well, I want the cloner, if LED is on, cloner should be on, the disk should be on, and the tube should be on. But now the TV should be off. It should be the opposite. Now there's a node for that. If you right click, you go to new node, Xpresso, I think, bool, and there's something called not. And that's just like an invert. That means if it's true, it's false. If it's false, it's true. So that has now become the opposite. And now close that. So now if I click on my control, I've got my LED wall. And actually, I should hide the visibility. So now you see the TV is physically turned off. If I flip this, suddenly the TV, or this single panel, this plane turns on, and then my cloner turns off. So now I've got a control to be like, well, is it a normal TV or is it an LED wall? And I can just flip between the two of those. So then let's control the cloner. Actually, let's even just go into some of our size stuff. Keep it really straightforward. So the TV is easy. The TV, let's just steal the control. So I got my width and I've got my height. So literally, height and width. Cool. And then I think I want to change the local position of it. So let's go to the coordinates, grab the Y and say, okay, I also want to control Y. Y, and it's because I always want it maybe pivoting off the ground. We could also make a control to say, well, it's sometimes on the ground, sometimes not on the ground. I don't want to go super crazy with the controls because, we could go really, really, really far. We could spend like all day just trying to make this little tool better and better. But yeah, there's the position Y. So essentially I want to be halfway up the height. So now we can do a little bit of math. So we can right click, say new node, Xpresso, calculate, and we can grab a math. Now, all of the lovely new tools that we have, well, like the new capsules and whatnot, that have all these really great navigation tools, some of which are in there because Rocket Lasso was consulting on it, where we could just like double click and you can search for a new node. You can't do that here. But I can click search here and then find it, and we'll start doing a bit of that. Anyway, here's a math node. I want to feed in the height and then change the math node to say multiply by 0.5 and then output that as the position Y. And right now that's only driving the TV. So let's make sure that we show the TV. And now you can see that now we got a tiny one, but you see it is pivoting from the axis of this empty instance. So yeah, pivoting correctly. Let's go into our LED wall, and yeah, the height is 200. The width is width of 200, height of 100, pivoting from the right spot. Now let's do the same thing on our cloner. So the cloner needs its height control, or like its Y offset. So I'll drop that in there and also drive that. So that wall will also offset. But now we need to control some extra things in the cloner. Now I think we're going to want several different ways we can do the math here, because essentially Cinema is already doing per step for us if we want, or it's doing endpoint. Either way, we need to do the math. So I think we'll do endpoint. So I will say that it's a size, which is a little bit of a pain, but let me show you. This can be something we can control. So the cloner, this parameter is a vector. So I can drag that in. Actually, if I think about it, we might be able to go into the effector. There's a lot of settings. Go to object properties count, you can split them out as 1, 2, 3. But you can also drag it out as its vector, which I've done. So why don't we just work from that vector? So actually count, I don't want count. I want size. Remove port. So yeah, you can right click and you can say delete port. And then let me try again. I grabbed the wrong vector. I wanted size, and maybe we can drive it. But anyway, that's a size. It's a vector, which means it's kind of like 3 different values. You see we got X, Y, and Z. So we need to build a vector. So that's not too hard. We can right click, new node, Xpresso. I think I haven't used these in a while. Probably an adapter. Yeah. So this would be reals to a vector. So it's going to take 3 real values. So like numbers with a decimal, or potentially with a decimal, and then creates a vector, and then we'll output that. So now we need to control our size, but pretty much it's X, Y, or it's width, height, 0. So we'll say width, height, and then it's already 0 by default. When you don't type in anything, it's 0. And I'll output that. And now we should directly see in our cloner that these values have changed. If I try and change it, it'll just snap right back to 200. It'll just snap right back to 100. So we have now kind of taken the height and the width to directly control the endpoint, but we want our LEDs to still be placed in a perfect grid pattern, which means we need to do the math for the count. So we do need the count, and we'll just, again, build another vector. If you hold down control, you can make a duplicate of it. So we will create a count vector. So we need to do a little bit of math here, which I don't think will be too hard. We're going to take the width. I'm going to duplicate our multiply just to steal a math node. Make sure you select the new one. This always drove me crazy. You see, watch this. Let me show you. If I click on this node and I hold down control to drag it, you see I'm dragging this. Now, when I let go, I've made a new one. And obviously, I want to work on the new one, but you'll see that the old one is highlighted. So I always would copy my math nodes, make a bunch of changes, and I think I'm working on that one. I changed it to like a divide or something, but I really changed on the wrong one. I've lost hours and hours and hours of work to that. Anyway, let's select the proper one. So what I want to do is take the width and then divide it. And divide is always tricky. You got to make sure you never go to 0. Divide by the density. So essentially that should be cutting. If our density is 4, then now we're taking a width of 200, dividing it by 4, and that's how many dots there should be. So let's duplicate that again. And I want to take the height and divide that by the density. And now that's width, so we'll pipe that in. And that's height, we'll pipe that in. And then for depth, we want that to not be 0, but 1. So I'll type 1 in there. So now let's go check out what we've got. So now if I flip my LED wall to be an LED wall, now look, we got an LED wall and it's pivoting from the right spot and it is adapted exactly to the size of the LED wall. Any question, or have I been losing anybody? Let's hit save. It's no one. We're answering the general question of how to make an LED wall, but because it's a relatively straightforward question, we're also turning it into an Xpresso rig. So here's a cool trick. If you've never done this before, you can go inside your user data. So I'll say manage user data. And right now you see my controls are in a category called user data, but I can say make a new group, pull that out of the user data group, and then I don't think we can, we cannot rename that one, but I can make this group and rename it to just be LED wall. And that is now a group. And now I can grab all of these parameters, move them into that new group and say, okay. And now my tab is actually called what I want it to be. So we got LED wall. So, okay. So now I guess, I mean, we did just tie in all the controls that we needed to. So now let's play around with it. Oh yeah, I would probably use Xpresso to turn those on and off. Maybe we could go and do that. Yeah, that'd be kind of fun. We'll go back and do that in a moment. Okay, so LED wall. So now it's pivoting from the ground. So now I can grab our figure and everything and reset transform, and I can see it sitting on the ground. So now we need our LED wall to be taller. So, or let's stretch this out. But look, here's what's cool. It's Xpresso driven now. So now as I make it wider, do you see that we have the proper number of dots automatically adapting to the size? And then I can increase my height, and now the height is going up, and now we get exactly a height, and we've got the exact density that we want. So I'll move the figure over here, and then actually, why don't I hold down Control, make another figure behind there, just so we can kind of see when we're viewing through it. Also, I'll tell our dome light to not render in the background. Okay, cool. Now let's go to Redshift, start that render up again. Okay, so now we've got our LED wall. I would like to modify that. The client says actually their DPI is going to be higher. So instead of 4 centimeters, it's going to be 2. So I'm going to change that number. And now there are twice as many LEDs on each axis, which actually means there's 4 times as many LEDs. And look at all the additional resolution we just got. It automatically adapted to it. It looks really nice. And you can see that we can barely see the figure through there. And I can rotate around. And then if we were to, I can't just disable it, but I can say don't render. And that, I guess I don't want to do that. Oh, we would turn off the lights, which is something we can do. But I don't want to keep on adding more and more controls. Like we could say, hey, the lights are on, the lights are off. This is that, this is that. But yeah, you can see that we can control the density now. I can set it down to 1. It's going to be a very, very high DPI. We can barely maybe see through it. But if we zoom on up, we will see that it is made of, okay, it's so small that they are intersecting each other. So obviously don't want to go quite that far. But let's do 1.5. And now very high density of the LEDs. So obviously every little aspect of this is another thing that we can control, modify, change this however we want to. Changing that we can make a control to control the radius of those dots on there, all doing the exact same thing we just talked about, just doing it again and again and again. Just for, so I'm essentially going to be wrapping this one up. If anybody has additional questions kind of following up on this, or like, oh, it'd be cool if you add this, like because you actually want to see it. Obviously it's easy to think of things to add, but the one last thing I'll do is, because I did go to the trouble of making this LED wall with a checkbox, but now that doesn't work, I'm going to actually just build it into the tool that if this is turned off, turn off all the children. So let's move into the tool, and we did all those lovely enables earlier. And now what I would like to do is say the LED wall, which is that LED wall, but I'm going to go to its actual enabled state, which is right here. I'll just drag it over. So that's if that is on. Right now we're saying, let's keep it simple. I'm going to look at the cloner and the 2 children. So these are always getting the same thing. So if it's enabled, And this is saying, and if that LED wall is there. So what we need is if the LED wall is true and if enabled is true. And the key word there is and. So we need a bool. We need a Boolean operation for this. So you can right click, new node, Xpresso, bool, and there's something just called a bool. So we make a bool, and you can see that it's got a very simple function. It wants two inputs. So here's the LED wall. Here's the enabled. And I'm going to say if, and the default is and. So you have and, or, zor, nand, nor. I'm not sure how to pronounce this one, zor. But pretty much 90% of the time, 99% of the time, you're using and, or you're using or. So this is pretty much saying like, if both of those are true, this output's true. If one or both are false, it will output false. And that is actually the state that we want. So that is now my enabled condition. And that is outputting to all three of those. And we also have to make a custom bool for our TV. So I'll make a copy of the bool. And this is going to say essentially the inverted version of that. So I'm going to say if this is inverted, so if that's off, and if the enabled is true, then the TV can be true. So the entire point of, so it wasn't too hard. So we've linked those together. And the reason to do that is now I still can go to my object and I can still flip between the TV version and the LED wall. But now if I turn off this checkbox, then you see all of them turned off. So it's automatically driven via that. Now we could also turn off this plane. It's not really doing any calculating, so not a big worry. So for the most part, we should be able to collapse that down and just not even worry about this object. I mean, if you wanted to, you could probably even go in here, and I almost never ever do it, but you can twirl down your icon and we could load a preset and you got like these different icons. So it's like, oh, this controller eye, that's a pretty good TV. So that changes to my icon to be my LED, and I could change that icon to any color. And now turning it on and off actually turns it on and off thanks to Xpresso. So let me think. The one last thing is I just want to say this was something I always did to be organized. People get intimidated by Xpresso. And even here, you just saw me step through it. So maybe you're not thinking of this as too intimidating because all we did was a little bit of math, very simple bool. We made a vector. So like not too crazy of a thing. But if you were to just pop this open, you'd be like, oh man, what's even going on here? And then if we just kept on going, if we worked on this for another hour, we might have 4 times as many parameters and different nodes going around. It's going to start getting like very crazy looking. So something I would typically do is colorize a couple of key important things. So typically what I did is I would just make anything that's a control, I would make like this very bright green. And then I would say anything that's actually a physical object in the scene, but isn't an active control, is going to get green. And I'd usually make it like a really pale or desaturated green. So it's like, okay, and that's just my personal thing. That's not like a rule that's across the board for anything. But it's like, even at a glance, now if I were to zoom out, I could be like, oh, like there's where my control is. And it's like, oh, and these are objects in the scene that I can go and find. So just something I would do to keep it clean. Phil, you tried using set driver, set driven in a Redshift material the other day. And it did make an expressive tag with a new null. So you think it's possible to drive a mission. Well, let's do a test because here's a bug I found. And we'll see if it's true. So if we make a material, so you might think, and maybe it will, I can drag this Redshift material in here. And it did. Okay, it dragged in. You see we did get this Redshift material. And if we click on the node, you can see that it's like, oh, okay, this is a node and it is linked to this LED's material. I'm hoping this will work, but now I'm going to hit save. So I'm going to hit Control S. Okay, it looks like they do have this one working. So maybe we can. So here is I thought if I hit Control S, if I saved, I was going to delink it. Let me show you. Actually, this is kind of interesting. Manage user data. I can say add a new data type. I'm going to add in a link. A link. So this is a link to an object. So now you can see I've got this new user data, and in that user data, I can say, hey, link to, maybe we can link to a material, but not a shader. Yeah. Okay. I'm going to link to that. If I hit save, that's fine. But I don't think that's actually what we want to do. Because maybe we can, maybe we can't. If I say outputs, those are getting output. Okay. This is important. We're learning things. We can get these outputs, and that means I probably can. Oh, let's see if I try and If I try and select the material and then output the weight, that is not being output. But can we manually find it? Emissive weight. Okay, so it didn't allow me to do the drag, but it is here. I just want to show you as the thing I thought I was confusing it with, and I'm curious if it would work with Xpresso, is let's do something real simple, like make a color. I think there is something just called color. Yeah, so here's color. So, okay, cool, here's color. And I'm going to want to control this color parameter. So what you can do is essentially drag a node directly, but you can't drag the node, but you can always click the little icon and drag it. And I can see that it did indeed make this color node. And you see it's linked to that node. I don't know if it will or not, but I'm going to hit save. And look, as soon as I hit save, it deleted it out. It just went away. And then you see this turn yellow saying that was broken. So same thing here. If I go to my data and if I link to this specific shader, it's there, it's working. But as soon as I hit Control S or save, it breaks the link and it goes away. So I think that's just a bug. So I thought we were going to run into that bug. But it looks like as a material, it has like certain things that are propagated up to the top, and those seem to not break with that save bug. So let's go back into our user data. I don't need that, but I do need a new data. And we're going to call this one brightness. And this one will be a percentage, and we won't clamp it. And the default percentage, I guess I'm just going to type in what would be the actual, well, I guess we're typing in 15. It's a percentage. I mean, well, you tell me, like, well, let me show you. I'll just type in 100. So it's 100%, and 100% means 1. Okay. So now we can have our new parameter and say, I want the brightness to get output from the original thing. I want that to output and control the weight. And assuming this works, you see the LEDs. If I scroll down to the weight, you see it's equal to 1. I'm going to pop this out just so we can take a look at it. So you see this weight, it says it's controlled by Xpresso, and you see it says 1. So would we want that to, like, Redshift calls it 1. So would we want this parameter to say 1, or do we want a brightness of 100%? And I could do a brightness of 1,000%, which is going to translate to 10. And I could do I can go up to 2,000. So 2,000% brightness, like, which communicates it better. These are just like artistic decisions you need to make. If you're a technical director, then you need to be making something that the team is going to understand. And in this case, I'm not sure which would be better. Like, on one level, it's like brightness 1 maybe makes sense. Yeah, I'm not sure. Now, in this one, I'm actually linking to a material. So when I was linking to something a little bit weirder, I usually would make it blue. Once again, just kind of actually, no, not blue. It would be purple, because blue meant Python. So I can close that. So now let's see if this works. Redshift render view. Let's start out with 100%. So we got some dinky little LEDs here. Let's make sure that we are in LED mode. So very dim LEDs. But now let's crank them up 10 times brighter. And yeah, that does seem to work, which is cool. Now let's make them 100 times brighter. Yeah, now that's an LED wall. Now we're talking. Yeah, okay, I'm glad that we are able to link to that. One important thing, I mean, obviously that material is indeed linked here. Linking things to a material can be a little bit dangerous because, and let me show you, it's actually quite dangerous to do. And that's why I really want to do it in the cloner. And that is, and I'll save this because everything's working. But if I were to take this LED wall and copy and paste it, there are now 2 LED walls, but only 1 material. Which one of these Xpressos is controlling our LED? And that's what happens when you're kind of remote linked into something that's not part of the same hierarchy. So I'm pretty sure it's going to end up being the bottom one, or whichever one calculates second. But I think both of I pretty much 99% is going to be this. This one is saying, okay, LED, you should be this brightness. And then this one's saying, yeah, but no, you should be this to brightness. So if I were to grab this first one and say, actually, you're only supposed to be 100%. You'll see, look, oh, actually, no, it's even worse than that. Look, it's fighting and it's just alternating. I'm not even moving my mouse and it's going bing, 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 bing. Doesn't like it. So that's something you gotta be a little bit careful about. So now you could manually relink the material. I'm trying to think of, and then Cinema might be trying to be too smart. Like, typically I wouldn't have done this type of thing. If I copy this object, open a new file and paste it, I'm going to not copy that over. You see this LED light did come along for the ride. So copy and pasting it between files did indeed work, and it would work fine here. Like if I drop the brightness down to 0, we should see the material turns black. So it's working here. But I think Cinema is kind of smart, where if I copy, maybe because I changed the value, it won't be. I'm going to copy the LED wall and go back to my first file. And when I paste, okay, so Cinema is super smart along these lines. So something interesting happened. Look, it made a new LED material. It made a new LED material because it was technically different. But remember, the other one also came along with a reference and the metal material, and it didn't make 2 of those. And I think what Cinema does is it is like, oh, you're bringing a material. That material has the same name as a material in here. And Cinema's not like, well, let's just merge them and assume. I think Cinema does a function where it goes through and checks every single parameter. And it's like, are all of the parameters exactly the same? And if so, hey, they're the same material, we'll just merge them together. So it's always been optimizing like that for you. But if, and let me just show you, so a bit of an experiment here, I'm gonna hit undo. If we copy that LED wall and go into a new seed file, I'm gonna paste it. Don't copy that over. And now I'm not going to modify it. I'm not changing the value. So now, again, I'm gonna copy that LED and go back into this one and paste it back in again. Look, now it didn't make 2 LED materials because the values were identical. So it's the type of thing you can't be too careful about. Like, I mean, it's going to be easy to break that link and not realize why it's breaking. So very specific. I mean, it makes perfect sense of why that would happen, but it's something you'd have to pay attention to. Yeah. Anyway, I think that's going to pretty much wrap this LED wall up. It's pretty cool. I dig it. And I mean, they do look cool. Like it's a much cooler looking effect here than if it was just like a regular old wall. Like just the TV. If I turn on the TV, it's like, oh, that's boring. But you turn on the LED wall, it's like, oh, now we're talking. Let's crank up that density again. And maybe the brightness is a little much. Okay, and we pull back and look at it, your little dots, like instant techie cool look. And keep in mind, we could be throwing in all sorts of different things. You can make it super MoGraphy. You could even have like random bulbs burnt out, like with I guess I'll leave Redshift open. And anything we throw in here, keep in mind, could become like another control. But with the cloner, it's got the plane effector. So I'm going to say, okay, the field. Let's add in a random field, and the random field is also, I'm going to say, normal. And we'll turn that on. And now you can see that every single one of these has become a random color. I set that to random, and now pure static, kind of cool looking. But yeah, pure static there. But, these are just overlaying on top of each other. So we could say, okay, but you are overlaid. So now you can see I've added random variation on top of what would have been the image. Go to blending and pull back on this, and now we could lighten it. So it's like, okay, look, little imperfections in between. And actually that does add to the effect of like making it feel like it is distinctly an LED wall when you kind of get these little variations and imperfections on there. We did have like we had the little glints on all of them. So right now they're reflective. So depending on the angle and the rotation of those, it might have an effect on things. So you'd have the option of adding in just a straight up random effector on there. And, just because this was made by people, like there's going to be little imperfections. So we can say, hey, okay, there's going to be a 0.1, 0.1, 0.1 variation in the way they're placed. Look at this, like barely offset from each other, but just like a little offset. Like even that might be a bit extreme. Same thing though. We can go to rotation. Say, yeah, you can rotate up to. That's a little light. Let's say 555. Yeah. So I'm going a little overboard. But look, now there's all this little imperfection variation on there. That means they'll catch different little highlights at slightly different angles. They're going to look a little bit different. And these controls, like I could make another control that just says like imperfections, and that control could simultaneously modify this random fields blending and also be applying how much this random should be getting applied, and it'd be just changing the slider perhaps. Or instead of that, you could promote up like the X and the Y and the Z as a vector, and then be able to type in how much you want those to be able to randomly rotate. So yeah, now with those random rotations in there, I don't think it's going to look very different. But yeah, just a little bit of extra imperfection there. And it's like, as we look at that, do you see the imperfection? But as you layer those things in, they catch different little highlights. If this was an animation where we're rotating around, every one of the LEDs wouldn't be getting the glint at the exact same time. It'll be a little offset from each other. So I really love being able to add in those types of imperfections on things. Because right here, does it look different? Like, no. But if I were to get rid of that random and get rid of this random, It's definitely a difference between those two. Boop and boop. Yeah. And yeah, I think this imperfect one feels more real. So anyway, yeah, that's pretty fun. Thanks for the question. I was tackling something real old school that I had not done in a long time. And I mean, like I said, we keep on going. Something that we always had was like a big frame that would go around it. You can imagine that we could build the geometry that would interconnect all of these behind there. Like I said, the frame, you can make it double-sided. There's so many things we could do to layer that up. But yeah, I think that's gonna wrap that one up. Yeah, we spent almost an hour on it, so hope everybody enjoyed that. But yeah, thanks, Phil, for pointing out the that you could drive a Redshift material, you just can't drive a Redshift node. It's not even a Redshift node; it's node. Okay. Do we have any? District is asking about showing fluid simulation. I mean, obviously, there are entire fluid simulation. There, you got everything back from back in the day of real flow, and then X particles has some nice fluid stuff. Now we've got the new particles, and the new particles don't have what you'd explicitly call fluids, but they do have a couple things that can make things look kind of goopy and kind of stick together. I wonder. I kind of want. I kind of want to try something a little different. I want to play around with rigid body simulations, which we almost never touch because I don't like. Just don't think I like them as much as the old simulation as it is right now. I hope the things I don't like start working. But now, and then I'm a little worried about making things really tiny, so I might make it bigger. But well, you said olive oil. Where was the specific question? Like specifically olive oil dripping over something. What's funny is like when you said that, I started picturing olive oil pouring on the top of an olive oil bottle. I'm trying to think of. I guess that doesn't really make sense. So why don't we see if in the models do we have some bread? This would be there's just that. Let's search for the word food. We should have some options. See if there's something that would actually make sense to pour olive oil on. I mean, obviously, it doesn't explicitly have to be olive oil, but yeah, there's not much. I guess there's an onion. You could maybe you're going to be baking the onion. So you want some olive oil in there. That might make sense. Reset. Zoom up. So let's see. Model nice and low poly. I mean, obviously that's not low poly, but the big question you always have to ask yourself when you're running a simulation is: are we making a real world scale or not? Generically speaking, I always want to go. Let's just call this dripping for now. I always want to work from real world scale, but it's entirely possible we're going to spend a bunch of time if we do this at real world scale and some value just doesn't work and it's going to look way better if we kind of scaled everything up times 100. Maybe, maybe not. Let's take the dangerous road right now and try and do it directly on this. Now, our onion, now that I look at it, I kind of want to see, that's why I wanted like some nice baked bread, which we don't have because I kind of wanted those imperfections. Because this thing's a little too perfect. Yeah, maybe I can. Well, I don't know. We're just gonna see what happens. I'm gonna, to begin with, we're gonna flip our onion upside down, and then we've got this model. I'm always inclined to get a very clean, mesh if we're gonna be running simulation on there. So I might pull this out. And let's see what just that one does. So yeah, that looks like this. I mean, maybe the oil could, flow over there. And it looks, ooh, I'm not sure if that is watertight. Maybe it is. But anyway, I'm just going to throw the subdivision version directly into a remesher. Love me some remesher. Adaptive, no. Poly count, lower. It's kind of weird. Is there double layers there? What's going on here? Oh, there's. Oh, okay. There was double layers. Okay, that looks a little bit better. It's kind of the way it's stretching around. I kind of want those to look a little bit more square. It's not the biggest deal, but they're not that square. Very much not that square. I might just ignore that. So good enough. I'm just going to make that editable. And why did it suddenly get very subdivided? Now I'm confused. Remesh. Wait, what was going on there? Do I go back and investigate? See, that looked really low poly. It's at 50% of the original. You can even change the value. It refreshes. Cool. So I say, okay, remesh, editable. And now suddenly it's super different. Now, what do I think is happening? I think it's ignoring the subdivision surface. Oh, that makes sense. That's strange, but it makes sense. So right now it's viewing it from the viewport, but when we make something editable, it looks at the renderer. So if these both said 1, then this would have been what we're seeing. Okay, cool. Mystery solved. Makes sense. And they're a little bit more square, but as we lower, it's probably going to lose them again. Anyway, good enough. Editable. Okay, problem solved, mystery solved. Collide. Okay, so that's our collision object. Now, what I think I want is going to be a little teeny weeny cube. So, and even this cube is where we go back to the simulation. This cube is nowhere near as tiny as I need it to be. So 0.1, 0.1, 0.1. That's more what I'm talking about. Now, I want to use we could probably do particles, but I want to try and stick with simulation here. But I am going to use particles just as a way of creating these. So yeah, we will do that. Particles, basic emitter, teeny, actually, essentially, I don't know if 0 breaks it, but I'm going to say 0. 0, boop, and I'll spin it down because why not? Cool. Basic emitter, particles, cloner. Clones is going to clone these. We'll worry about turning out clones in a moment. Let's just deal with our particles, which is pretty much I just need a rate. And we need particles to be created at a certain rate. So there it is. It's firing them. I'm going to say the rate seems okay, but I'm going to say speed 0. So honestly, I think that's all we need. So now cloner. Cloner is going to clone onto an object. The object will be the particle group, and they can't be multi-instanced because we're running simulation. So now, if I hit play, we should see a cube, but in theory, there's more and more and more cubes being created. So then we right click and we say, I would like to add on a simulation rigid body, and gravity should still be turned on for those. So now we hit play and let's see. Okay, it's really chugging. GPU. What this? All right, I'm gonna do a couple things. Let me make my emitter a little bit bigger again. Just want to see something. Hit play. Yeah. Okay. So they were intersecting and kind of flipping out because they were intersecting. So we are going to calm this way down for 1. And it looks like gravity is pretty, this might be some scale stuff starting to trip us up, but let's go to our scene. We're going to say, just to start out, we'll just go real easy on our gravity. Okay, so now you see, now we're getting something controllable. It's not flipping out. So now that we see a little bit more control, although I can say my speed is kind of absurdly slow. I'm trying to think of why that might be, but let's see what we can do. For now, I'm going to go to my collision. I'm going to say that the collision shape is not auto, but instead is going to be sphere-based. Thickness, these are real tiny, so I'm going to say 0.1. Hopefully that's fine. Why? This is why I don't use, see, even that. Why did, look, now it decided to start going really fast. And now it goes slow. And then I get like a hiccup and it goes really fast. If anybody knows anything specifically, please let me know. But those are being very disappointing. Simulate particles legacy. This is going to be silly, but I just want to see what happens if... what happens if I just emit from here instead? Very silly, but I just want to see if there's a difference. So just clone onto there. Should be the same result. Might be a different rate, but yeah, so those are shooting out real quick. Emitter, particle speed 0. Okay, cool. Nope. Like I'm making 4 little cubes and the simulation is like choking. It's like, this is not... It shouldn't behave. It should not be behaving this way. And it didn't behave this way when I recorded my video of the simulation stuff. So I can't help but feel there's some bug that's been introduced that it just does not handle this. Now, I'm never one to be deterred. So let's just see if this is maybe an issue of per step 0.2. 0.2. Is it that they're constantly changing their count, or maybe something to do with the emitter and the way that those are interacting with each other? So let's make ourselves say endpoint. No, per step. That's, yeah, I did want per step, and now we can say like 5 by 5 by 5. So I feel like that's more than we had made before. If I hit play, running, not amazing. Like, I feel like we should be getting more than 10 frames a second with how few cubes there are. Let's add on our collision tag. Triangle mesh collisions. I mean, even slower because now it's going to be colliding. At least they successfully collided. That's good. But is... I know. I'm actually a little stumped as to what we should even do, because I really want to try and do this with stickiness, because we haven't played with stickiness in a while. But like, we're just like, I want there to be, like, I feel like this lag we're seeing isn't even a variable of like how many particles there are. I feel like we could throw a lot more particles at it and we're still going to be getting a similar rate. Like, let's make it 3 times as much. And I don't think each particle represents more slowdown. Maybe it does, because that's horrible. We can't continue with that. I don't know. I'll save this as a bug file and maybe report it. So cloner out. Like, let's try and go with basic particles, but you all probably know that I am not a big fan of the collisions. Like, the collisions always give us trouble. So maybe it's the same system is like not going to be working for us here either. So now we're back to regular old particles. Particles are being created. They are going to show up a little bit bigger. They are going to have gravity. Gravity is going to be real high, so we're going to lower that again. We're going to give ourselves some extra frames. Okay, so we got particles weeping their way down. Size is 0, 0, 0. So now we got like a constant stream of them going. And then I'll save it as B. And let's see if we can get them colliding. Collide after gravity. And that should just automatically see, like, they want to bounce, they want to collide with anything that's got a collision tag on it. Play. Yeah. I'm going to say both sides. Like I say, I'm not seeing a collision. Scoot this over here. See if we can get some deflection off the side. Yeah, that's not colliding. Um, is there any chance it doesn't like the collider tag and it would instead prefer a rigid body tag? Rigid body tag. Now it's obviously going to fall. So I'm going to go forces. I'm going to say strong follow, strong follow. So in theory, it doesn't want to move. It might move a little bit. Not seeing that. Collide, target group, exclude, select consider geometry. Let me deselect everything. Select this and say select consider geometry. And you can see it did select that, saying, like, yes, it is acknowledging that. And we were just simply not getting collision from it. Now we've got this thickness. Remember, we're a very small scene. So I'll set down to like 0.1. See if that does anything. Interesting. As soon as I set that down to a very small amount, the frame rate dropped. And now let's go to our particle settings. Yeah, we've got all sorts of that. Compactify should have nothing to do with it. Yeah, Paul, I'm with you. There's just something wrong with this. Because this should be a really straightforward thing. And every time we get a particles question that has something to do that requires collision, and it just is never working for us. So now the simulation wasn't working, and now the particle collision is not working. And I don't understand why I get these hiccups where it goes fast and then suddenly goes slow. So yeah, if those aren't colliding, and then here's where things get real annoying is, okay, it doesn't like the intersection mode, which should work. It's very clean geometry. Instead, I'll say, give me it based on a radius. And now the radius is huge. So we'll say, okay, 0.1. And now let these fall. And now, look, first of all, well, yeah, I'm not even, how do I explain that? What's going on there? 0.1 is size of cube. It should be like like really, really, really tiny. So like doesn't like that. Both kill like tiny radius. Now this does have this thickness. So again, let's drop that down to real tiny. Maybe that's like an invisible force field around it. So reset the simulation. Nope, didn't change it. Still colliding way on the outside. Yeah. Anyway, great question, but Cinema does not want us to answer that one today. I guess I can save this as Bug Part 2, since it's essentially a completely different thing. Doing similar problems. Okay, we'll just shift to another question, because essentially what I want to get is some goopiness going. And if we can't use particles with their flocking behavior, and if we can't use the stickiness that we get from the rigid bodies, then we can't get goopiness. Which is too bad, because I think we have successfully kind of done some goopy tests. It's just not working now. Maybe something worth noting is that this is an empty shell. Now, we were saying collide with a triangle, so the fact that it's hollow, I don't think should really be making a problem. I wouldn't think. I only just noticed. So if we do select that, and then even here, I'm still not confident that that's not closed. So this was not a closed shape. I don't really think that should be a problem. That's interesting. And patch. Don't forget, we got that new mode patch. So if I click this, we can get pretty nice closed shape on there. Nothing changes if I hit play. Let's see if it behaves any differently. Nope. Not surprising there. Still doesn't like it. Save. Okay. Well, that's why I said district, where I was like, oh, is it a scene scale issue? But I think we've done stuff like way bigger. And honestly, it goes to if it's even if it is a scene scale issue, like we should be able to get it to work. So like, yeah, here's scene scale. I'm gonna drop it down to 1/10 or 1/100th of the size, and yeah, like is that better? What's even going on? Is the force field still back? Yeah, that's that 0.1. So 0.1 is real tiny. So force field shouldn't be doing that. Yeah, straight up, don't understand. Triangle mesh. Nope. Both sides, please. Don't worry about deformed. This collide doesn't have many options. Go back to just straight up intersection. But this is, this had been just passing right through. Oh, goodness. Why do we have such a massive force field around this? Because we got thickness, but I dropped it down to 0.1. And it even goes to like, if this was, even if we scale this up 100 times bigger, like that's a huge gap. If we make a figure, it's not like we're in some like infinitesimal scale. Like, it's tiny, but it's not like look at the gap on there. Like, even if we were way bigger, would you want those particles bouncing that far away from the figure? Zach, that's a very good point. I did forget that. The particles themselves have a radius. That could be a variable here. Okay, that solves at least that specific problem. How much of that? Well, I guess let's continue now, because maybe, well, even when I don't, that we might need to keep that in mind. Maybe these particles will behave a little bit better right now. We got to do some tests. Still not going super fast, but that doesn't change the simulation stuff we were just doing, because the particle radius wasn't part of that simulation. That simulation system, and we had their own little radius. I think that it was fine, but yeah. So now those do kind of feel like they're actually going from that 0.1 that I typed in here. So let's try 0.05, just half the amount. Let's see if they are going a little bit closer. Hard to tell. Yeah, it's kind of hard to tell. Bing, 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 bing. Little twitchy, a little bit slow, not super duper happy with that speed. But if we're getting something, then, that'll make me a little happier. So let's continue. But I would feel a little bit bad if it was just that radius and all this starts working again. But I'm pretty sure we would have accounted for that in the past, and not every time that this wasn't working. Okay, so let's see what we got. What settings do we have? Collide, friction. Oh, see, why is it right now? It's suddenly running smooth, and then it's going to start choking again. Why does that happen? Like, is it my computer, or is that something in cinema? Are other people running that where you suddenly get like incredibly good frame rate and then not? Let's try what happens if we go to radius, and if they get stuck. It's not faster. Seems similar, so I would prefer to stay on intersection. Very bouncy. I'm going to get rid of all of our bounce. So now let's see if they kind of slide around the side. Yes, they are kind of sliding around the side. I'll take it. Okay. Now, there's a surface attract, but I do not have good instincts on surface attract. Oh yeah, I can't drag it. Surface attract also looks at colliders, but like you've got this, I guess maybe attract does, but I just have a bad instinct for this. But I want things to, when it's close by, let's even say 0.1, I want them to kind of be stuck on it, but like I'm not sure that we're going to get a visual difference on it. Yeah, I'm not seeing a visual difference. So we won't worry about surface attract for a little while. All right, now let's just go straight into our flocking. So flocking, best modifier, bar none. I think it's always a good idea. I don't know this for a fact, but my instinct right now is you want to essentially have your colliders be pretty much the last thing that happens, because if some sort of motion, and this flocking is mostly particles being attracted to each other or pushed apart from each other, if you do flocking after colliding, then a particle might push another. It's like, oh, I collided with a wall. But then after I collided with a wall, the flocking told me to get pushed through, and I got pushed through the wall. So that's why I think collide is good to come later. So flocking, these are all very tiny. So most of what we want to do right now is going to be a strong cohesion, but with a very tiny radius. So we'll say 0.3. And then some separation radius, which is going to be, let's just say 0.1. And Yeah, you got your velocity alignment, and that can be, let's say, 0.5. Okay, let's see. The hope right now would be these are going to kind of blob apart from each other. Now everything's real tiny, and I'm going to make a friction. So after flocking, some friction will happen to slow everything down. And how far do we need to go? I'm virtually not seeing anything happen. We got to tinker, but is that friction frictioning? More friction. More friction. 1,000 friction. Doesn't feel like the friction is frictioning. 10,000 friction. Hey, that frictions finally. Now they actually look like they slow down. I definitely do not have an instinct for the way that the friction is applying the particles. There might be a little bit more going on. Also, you can see, it's hard to tell, but to my eye, some of these particles are like suddenly like boink, 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 and really popping away from the surface. So not the smoothest thing on there. Now, with them slowing down, I think we are actually getting a little bit of separation from them right there. You see how they are pushing apart. I don't want the friction to be frictioning that hard, but let's see what happens. Okay, so we got our overall strength. I have found that you don't really want to go above 1, but right now they're pretty close. Separation radius 0.1. I'm going to say 0.05. And a little dangerous, but I'm going to say collision increase that. Yeah. Okay, cool. See that little bit of kind of overlapping there? That's what I want to see. Oh, there's little brief bursts of like high frame rate. Like I desperately want to have that all the time. Particle group. I'm gonna make them even bigger just so we can very clearly see them. Back into particles under color. Let's make a random, and I'm gonna load in some crazy gradient. Let's make them neon. Why not? So it's randomly choosing from there, and that's just so we can actually see, like we can kind of distinguish them before it's kind of like all blending into each other. Cool. And then save, and I'm going to emit way more particles. So let's jump this up to 3 times the amount. So they're all kind of blobbed on top of each other, but then eventually they can start separating. That is what we want. Keep in mind it is 3-dimensional. If I actually, it's interestingly 2-dimensional. I will make our emitter have a bit of scale, 0.1, just so that should be enough separation so they have some orientation. Hitting play, we should see them separate, but they still want to cohere to each other. And that's all thanks to the flocking. So we kind of got a little bit of a thick blob there. Now, let's let those run. And they start colliding. Now, like I said, I don't like what this friction is doing. So I'm going to turn that off, and we're going to make a math. And before the collide, the math is going to say that the velocity speed, we are going to set, or assign rather, to the velocity speed. You could also just say velocity, but I think velocity speed is what I want. And I'm going to type in a value here. I'm going to say 1, which is probably way too slow, but this should just be overriding whatever's going on. Yeah. Now, in theory, I'm just setting this absolute speed, which is pretty slow. But I can say 3, and now you see it's 3 times faster as far as what their movement is. And right now you're seeing we get a really nice frame rate, and then it's going to drop back down again. So blobbing together, falling down, doing their thing. I'm going to make it a little bit slower because I want them to be goopy. Right now, I'm not liking, you might be seeing it too, where these are just kind of popping around and not a great way. And considering we're doing a collision with 0 bounce, let's try giving it a little bit of bounce. Why not? A little bit of bounce, collision. This is a rigid body. Remember, we got rid of our collider because we weren't trusting it, but I want to try and put the collider back. Right click, simulation, collider, collide on both sides. Bounce and friction shouldn't really matter, and it's a triangle mesh. Run. Okay, colliding, it's still popping that same way. I can't account for it. I don't know why it's doing that. Okay, so now the question is, can we get this to be kind of goopy? So let's go to our top view. Ooh, big old hiccup there for some reason. Figure, don't need you. And I just pretty much want to center this over the top part to get maybe some randomized flow. So, um, okay, little jittery guys. Just because I'm always up for experimenting with stuff, let's move the collide to be the very first thing that happens and see. Okay, you do see that everything just passes right on through, so obviously you don't want that. And move after gravity. So after gravity does work, but like I'm still worried about, like I said, that flocking things might get forced through. But even now, like having rearranged the order, like that doesn't seem to change too much there. Friction's not doing anything. We can put the math earlier. I'm experimentally moving some things around. Honestly, a lot of these aren't even doing anything. Um, and it just doesn't seem like the order is in this particular case changing anything. I think most of the time you don't need to worry too much about order. Collision is the one I tend to worry about most, but these are still just popping around, and no order seems to fix those. Radius, there's that, I don't know if it's a bug, but there's a thing with radius that they just get stuck when they collide. You can see it did kind of feel like they collided, but they're offset and they are not working great there. Repel, I don't even know. I have never really played with repel. It's like that feels like I'd kind of try and push it away, but I don't feel any force pushing it away. So anyway, keep in mind those limitations. Right now, we're not centered so much that they're flowing. They're not like pooling up. So I'll try to move over here a little bit. It's going to be real sensitive. They seem to very much want to go one way or the other. Okay, collide, dynamic friction. Is that even a thing? I'm not sure I believe that that is a thing. Is dynamic friction going to actually apply here? Friction, I mean, there's some friction there. We'll turn that up. Yeah, is anybody feeling friction? Because I'm not feeling friction. They're kind of going two directions, probably because the stream is striking two different sides of this polygon. But yeah, I'm not feeling friction, which I wanted to slow them down that way. And it's still bouncing, which is bugging me, but ignoring that. Let's try and add more goopiness. I'm going to give it more cohesion strength from a larger radius. I'm going to say 1. And that's fine. Didn't really change much. Let's lower our strength here. Because I like I said, I don't want the strength any higher than it has to be. Cohesion radius 5. I want these things to start really wanting to hang out near each other. So those are still just like they're kind of blobbed up, but they don't seem to be too strong. So I will start increasing our strength here. So let's make that 5 times stronger. Okay, interesting. Like the radius is clearly enough that it's attracting them even from up there, which actually does make sense. So we'll make it tinier. Radius 0.5. They're still wanting to flow more than stick near each other. 15? 55? No, well, okay. I had to go crazy high, and they finally were like, oh, okay, we're going to try and hang out near each other. You see they're kind of gooping. Goop. And then they go. Okay. Not great. Now we'll increase our separation strength, which honestly should be stronger. I already said I don't want things to be higher. That's interesting. Those are, well, like I said, this is what happens when you start doing values that are really high when it comes to flocking. We're just not quite getting the goopiness I want. Yeah, they're not gooping. I thought we could get some lovely little liquidy blobs going. It's kind of like, I'm going to save that again. I feel like we should be able to go further on that to such an extent that, like, let me show you the effect I want to do two-dimensionally. We'll see if it kind of works. Do I have my presets? I do. So here's just a nice quick preset I have to make that. And then let's do a similar setup. I'm going to make a flock. The flock's already applying everywhere, but we'll do flocking. And immediately you can see that these are starting to group together a bit. I'll make it bigger still. You can see that these are separating out a little bit. They're too close, and then they're starting to gather. I thought I increased my frames. Yeah, they start going into these little clusters. Essentially, we're getting these little globules. And that's essentially what I want to do. So if we make our cohesion radius bigger, let's say 15, and our push apart bigger, which is like, well, 10 is probably way too much. We'll just say 2. You see these little blobs start to form. And as we pick our radiuses carefully, we can have them spread out. That's a little strong. Yeah, now because of this cohesion radius, we get these lovely blobs. Like this is exactly what I want to have happen, but 3-dimensionally, that these blobs want to hang out near each other. So, obviously there would be some gravity going on, but you'd want them to still kind of want to hold on to each other. Keep in mind, this entire thing is going to be very 2-dimensional. We could push the effect further. Do I want to push the effect further? That's my question. By adding a little bit of gravity and maybe a collision object. Like if we make a tube. Make a pretty big tube. And maybe a funnel shape. So we'll mirror this over onto that side and spin it around to -50. Cool. So I got that all mirrored. These can be very close to 2-dimensional, as can this. And scoot them down. I know we're going right back into colliding, but at least this whole seems a little bit bigger. So all of those get a collider rather. And now we make a collide, flocking. After the collide, it wants to collide. All of these want to be triangle meshes. Yes, they can collide with both sides. Yes. And they're bouncing right now. That's fine. I don't mind them bouncing. Hit play. And yeah, this is drifting around. In theory, they're bouncing, but we need a very, very little amount of gravity. So let's go easy on the gravity. Now they will keep on accelerating. But, now, essentially, now I think, okay, we're losing our 2-dimensionality, which we can do something about. But, at this point, it's like, oh, things intuitively kind of feel like they're working a little bit better. Now we need to keep it 2-dimensional. So we'll say math. I think we want it. Do we want it to be the last thing and the first thing or right before collide? I don't know. So we'll say assign the value of 0 to position Z. So we're constantly telling them they have to be 2-dimensional. They can't move forward or backward. Now we are seeing a decent number of particles escape, but you can see a lion's share are staying above it. Let's make that friction again. And I just want to see if I can distinctly feel an effect. Yeah, see here 100 was fine. Why do we type in like 10,000 before to make it slow down? Like being a tiny scale, does that make that difference? I don't know. Slowing down, maybe they'll slide through less. It looks like one did get popped through. Oh no, Javid. Not Javid. Maybe it's Javid. Anyway, we started this out with the premise of like this is not a liquid solver, but you can fake some stuff pretty well. But what I wanted to get working essentially was some good blobbing going. And even here, like I don't know how much of it's kind of fake, but like with the how do we communicate this? If we make, I might just make way fewer particles because what I want to do is see a blob go here and it kind of wants to flow left and it kind of wants to flow right. But because of the cohesion between them, which we get from the flocking cohesion, they wouldn't want to let go. So this emitter is fine, but I'll make a duplicate. And this one will be much smaller and much fewer particles. And way lower. Go. Blurp. Maybe too many, but let's just see what happens. So we got a blob. It definitely feels kind of blobby. And it's going around the sides. And the hope is that it doesn't, if we get the settings right, the hope would be it doesn't want to tear. It's stretching right now, and I think that makes sense. Like, and if you imagine this two-dimensionally as like some olive oil, that's kind of like, oh, the sides want to hold on to each other a little bit. So, I mean, that all felt pretty good. I mean, eventually, you know, I would expect these are going to, like, yeah, they kind of want to stick. You know, you can definitely see that those would want to go. They're able to stretch apart, but eventually, yeah. So now they've kind of torn, and I think they'd be able to go. But you know, in this very kind of simplified playground we've got here, we go back to flocking. That's the cohesion radius, which is pretty big. Well, you start saying the cohesion is even stronger. So that's even going to potentially bring this into little tighter little bloblets. But yeah, you do start getting that jitter. Keep in mind that your velocity alignment is really important. See that jitter we're getting? But if I change this velocity radius or alignment radius to 20, I think that those will, I thought that would count a little more. But that's 2, so maybe this needs to be 2. Not quite. But yeah, when you start putting the values above 2, that's when I think you might start getting that jitter. Or above 1, rather. This cohesion above 1. Maybe not. I'm not sure. I'm kind of inclined to like go even further. If I'm going to keep on increasing my cohesion. And then we have to do the separation strength as much. And yeah, immediately more jitter. Little bit of a worry on that. But even with all this gravity, if we have the right amount, like, can we make this thing want to be like, no, I'm a big blob and I don't want to like squish down too much? Like, maybe. Definitely feels a little bit more blobby, but is it super sticking on? Hard to tell. I mean, definitely still falling. I mean, could we make it be a full-on blob? I don't know. Let's go 1, 1, 1, and then 5 on the strength. Is that just, I imagine the strength multiplier is just the equivalent of saying that's stronger, and that's stronger. It's my assumption. Same jitter. Let's try giving ourselves an extra stub step. So that's 2 sub steps. 2 sub steps does make a big difference, but how much is that going to help us here? These very much want to push apart from each other, but they have a very strong cohesion strength. That's a much larger radius, so you get the bigger blob. Very jittery, keeping the blob-like shape, but still kind of melting around. There's not a limit of particles. How big is 15? So that, okay, good to know, actually. So you always want to get a little reference. So that's 15. That's a radius of 15. So any particle is looking at a particle that's up to 15 away, and there might even be a fall off on that, up to 15 away, and being like, oh, I don't want to get too far away from you. So maybe we need much larger radiuses for the effect that we're looking at here. So what about radius do I want? Like, you know, if the particles really want to hang out near each other around that, which is right around 50. So let's see what happens if we say that's the cohesion. I mean, that one turned into a little bit more of a blob. Let's see what happens here. It's definitely gravity. Yeah, at this point, yeah, stuff starts getting weird because you see gravity doesn't feel like it's doing its job properly. Like, they're not falling down too much. They're very much getting pulled into each other. I guess the particles on the outside are probably forcing the particles on the inside into each other. So we might need more separation strength. But now, you know, now we're starting to get a lot of jitter because we have a lot of kind of conflicting energy back and forth. Now, maybe more substeps can, oh yeah, that actually worked pretty well. So yeah, more substeps. Yeah, okay. So a lot of substeps on there, pretty strong, or a large radius and a really strong separation to push them apart because they're like, no, I don't want to get too close. And now you can see that we've got like this little blobby guy, and he doesn't want to separate. It doesn't want to break. I have to even kind of imagine that if I were to make a copy of the cylinder, I think this will work. If I move this around and boop it in, gotta do it kind of slowly. Hopefully that's working. If I boop it in, it's kind of like it's still breaking. And then if I pull it out, oh yeah, they just passed right through. But do you see even before those got there, it kind of like reformed in the center. Like the radius is large enough that they're like, no, we don't want to leave. So in theory, like an even larger radius is going to make them maybe turn more spherical. They're pulling in the center, so you need more counter separation strength. But yeah, they're getting pulled back in. They don't want to fall. So yeah, this cohesion radius is a major variable. If I say 25%, that's half of what we kind of had working. Bigger blob, because now the separation strength doesn't have to work as hard because particles from the outside aren't stacking their energy to push the ones on the inside more. And now, in theory, I think we'll get more blobby. So yeah, it goes to, and keep in mind that making this type of kind of 2D environment is a really kind of fun way of keeping it a little more simple, like really kind of seeing what the dynamics of the situation are. Because I wonder if now, just as a kind of fun experiment, what if we let's just call this blobbing now. Blobbing. What if we make it 3-dimensional just for the exercise? So instead of this cylinder, we'll make a sphere. And that will be what we're colliding with. And get rid of that. And then essentially we need a cone. Easier to make than what we have, actually. And bigger, bigger, bigger. I mean, honestly, the cone's not even doing much for us right now. So let's not even worry about that. Turn those off because those probably aren't doing anything either. And then let's make everything 3-dimensional. So we don't need the math anymore. This emitter is not going to be a circle, instead a sphere with the same radius. And I don't know if we need 10 times as many particles, but I'll definitely give us 5 times as many particles. So now it's 3-dimensional. We got a blob of them. Okay, about the correct radius. So now, like I said, the gravity, all that energy in there is seemingly fighting the keep in mind, very minimal gravity. And even now we do have this friction. So if I turn off that friction, everything is a little bit more free to move more quickly. But even here, I think that blob will go out and be like, no, I don't want to go too far out. You can see the individual sections try and be like, no, we're trying to coalesce. And essentially, that's the effect that I want with the olive oil, is like this coalescing going on. And actually now it's blobbing onto there pretty well. I mean, so is the scene scale a problem? Because like this seems to be working okay now. But here's what's cool is we now went and made it from being 2-dimensional. We just swapped it. We just swapped everything to be 3-dimensional. And the properties that we implemented in the 2D world are translating pretty dang well into this 3D world. Those all sticking together. Oh, see, when it runs smooth, it runs so smooth. I don't understand. Okay, yeah, so those are all going. Now, we already learned that the flocking, like a larger flocking radius made a big difference. So if we say 50, we might get the jitter. We might have to push them apart a little bit more. But yeah, they're definitely like more blobby and wanting to stick together. Now, there's no turbulence, and they all shot off to the left. So that kind of goes into where there might be a little bit of weirdness going on here. But yeah, it almost like bounce. I mean, maybe it's just all those forces might be like it's just out of control now. It's just like all that ambient energy in here is like out of control. So that's where maybe not all that friction, but a bit of friction just to drain that energy out. Gravity acting kind of weak, so I will double that. So we're definitely getting that left drift still. Clearly, they still want to be a blob. And honestly, like that was a huge difference. All we did was change the radius of the flocking, single parameter, and it went from all those little blobs traveling all over to one spherical blob not seeming to want to go anywhere. So start splitting the difference. We'll do 35. Start it again. Boom. So strong enough that it did want to be a one blob and now a bunch of little separate ones. That's okay. See, that is almost, that's pretty close to why I originally wanted. This is exactly what I was trying to do in the very beginning, and it wouldn't work. Now we got a blob that fell, and its cohesion its cohesion is stopping it from flowing because there's like equal weight on every side. This is exactly what I was initially trying to make. But what about what we were originally doing, wasn't it? Was it the scene scale? I mean, also we got our substeps way high. If we say 1, let's see the difference. Very different. So substeps, huge difference on this one. Although, it goes to, I would still say huge difference. You see these kind of like getting flung, looking a little bit weird, but definitely still feeling like they kind of want to be coherent. I'm going to turn it to 5. You see each of them individually coalescing as these bloblets wanting to, now they're each kind of flowing, doing their thing. Okay, cool. So a lot of this turns into what is our magic sauce here. We already did 25, and 25 was enough. Well, I guess they're already collided there. And they recoalesced. I wonder. Oh, the friction's higher. I was gonna be like, why didn't they go flying out like they did that one time? Now it's lower. So is this enough for them to sort of like, they want to hang out near each other, but they're willing to tear away? And actually, yeah, it seems to be doing exactly what I want. You see, it's getting real thin on the top, and it's almost like this ring is forming. That is what I want. And is this real liquids? No, but are we faking them pretty well? Oh, look at me, little face. Yeah, look, that's like almost perfect. That's exactly what I want it to do. 3-dimensional, kind of liquidy forming thing. So now we got that initial blob. I'm going to make a duplicate of that, and let's have it make 100, but constantly. And I'll move it up in the air and make it smaller. Let's just see what that does. And I wouldn't be surprised if we get some slowdown. But essentially, I want to make a constant stream here. But the goal here is to kind of have a blobby stream that like it's going to have like thicker and thinner drips. Which, all right, like right there, you see definitely there's a little bit more of a drip, like a drop looking thing there, where it even kind of feels like it doesn't want to let go from the rest of these. Maybe true, maybe not. Where now we are going to be getting significant more slowdown as we go, because obviously we're generating new particles. But I kind of wanted to add to this and see what keeps on happening. Come on, keep going. I mean, we have a large radius, and all these particles are. See, this type of slowdown with something like flocking is a lot more reasonable to me, because every particle has a radius of 25 units around it, and it's trying to find every one of those particles and then figure out, like, relative to those particles, what effect it should be having. So that makes a lot more sense to me. So, I mean, I'd love to one thing I really like. So essentially right here, this is exactly the behavior I want. What's really exciting to me right now is we experimented with this 2-dimensionally, and it's translating into 3D like perfectly. Like I had you see thicker areas, and then we suddenly had a really thin area, because they want to form into these like little blippy droplet areas. Now the thing we're missing, and it just goes to, I don't understand, as far as I'm concerned, well, I just do not like the way the collisions work, because it just seems like friction doesn't mean anything. Like I can turn off the bounce, I can turn on the friction, and essentially in theory what that means is, like, with all this cohesion, that some of these particles they're going to strike. What I want is the bottom particles that are in contact with this are like, oh, I'm kind of stuck there, but then the ones on top of it are flowing on top of themselves, and it kind of like starts rolling over the top. But as far as all of our tests have gone, friction just doesn't seem to be a variable. Like it just doesn't. And it's like, maybe am I misunderstanding what friction means? Like I don't feel like I am. Now, and there might be even ways of faking it that, like, mathematically, or the calculation here would maybe be kind of dangerous. Because in theory we could make a field condition where it's like we make the speed go way slower. That'd be kind of funny. We could make a fall off from the surface of the sphere, and make a fall off condition that pretty much says like, oh, when this condition is met, drain the energy out. So then the ones that would actually be in contact with it would be wanting to go really slow. I actually kind of want to do that as an experiment. It would be kind of fun, maybe at some point, to make a 2D test environment that has the ability for me to like flip a checkbox, or like turn on a couple things and turn off a few things, and then flip it into like a 3D world instead of a 2D one. Because right now, the friction concept I'm talking about, it would be a lot better to test 2-dimensionally. So I will save this, but I did luckily save blobbing when it's still 2D. So we can go back here and tinker around again. So let's go and match what we had before, which was, that's fine, that's fine. But we made flocking 25. I think 25 is what we had. Gravity got stronger. Friction was turned on. Let me go back over to it. Friction was at 18. Gravity's at 22. Flocking is at 25. Overall strength of 5. 22. Gravity's at 22. Flocking is at 5. So, okay, that's the two-dimensional equivalent. Boom. Those are exploding outward, but what's our, yeah, and our frames are 5. But we're getting our kind of nice blobby flowy thing going on. They're just too compressed in there in the beginning. So we'll just make our circle bigger. Yeah, so they don't explode apart from each other. Important variable there. So hopefully similar-ish behavior. And then the experiment, now the blobs aren't breaking apart, but the experiment is supposed to be if it gets close to the surface, and let's see if that's still, if this still collides properly. Yeah, I just want to be able to see it. So here's the idea. If these particles get really close to the surface, that their speed is going to decrease. So we need a field condition. Yep, a field condition. And this one is going to be math.z. And this field condition is going to say when, I did not mean to make that. Go away, Python. When the geometry, I might want to make more than one. So here's a little trick. Throw your geometry into a connect object, and then don't link to the geometry, link to the connect. And then we can just very, very easily swap out the geometry just by changing out what is a child of that connect. So when the point is within, let's get real technical here. Let's say that distance, so whatever that radius is. So right around 7. When the surface, when you're within 7 units of the surface and you cross a 50% threshold, that should be enough to at least see some of them, then this condition should be true. So when you are close to the geometry, what do we want to have happen in that condition? Well, we're going to need a math, and we'll put that in the field condition. So now this only executes when that's turned on. And well, what we could do, what I want to do is multiply its velocity speed by like 0.5 or something. So it's constantly losing half of its energy. But I also want to make sure that this is just straight up executing. So let's make a color mapper, drop that inside, and say when, oh, it's already in that condition. Oh, yeah, not color mapper. We'll make another math. And this math is going to assign a color to the RGB, and we'll just say like 1. That might be red, it might be green. So now if it touches, we should, yeah, it's green. So you can see when the condition is met, it's green, and you see that is how close they were. So now I can at least tell when it's executing. So we could now grab this, and we could change the tolerance. I think if I, oh, okay, not 100%. Yeah, if we make it 99%, then yeah, you see it's a little bit further out because it's 99% of the fall off on this. Why did something go fast? So anyway, you can see that the couple of particles that are really close are getting that condition. And then, so those slowed down. So essentially that's giving us friction. So it's not like, it's not like the concept of friction shouldn't be working. So those all slow down. These are still able to flow over the surface. Honestly, we might want this condition to be like really tight to it, so I can like decrease this to only have the ones that are really close be highlighted. So in theory, they could get pulled off, and when they get pulled off, then they'll be free to like blob around again because gravity's still getting applied, and it's just slowing down their velocity. So let's see. Bloop, bloop, bloop. Changes. I love being able to stack up multiple maths to do this type of thing. I think it's really nice. Let's see. What are we hoping for specifically? I mean, essentially, we want to get a rolling effect, but these aren't blobbing apart from each other too much. But you know what? Essentially, I brought it into the 2D test world to see if it works. So you know what we can do? We're going to rename this to color proof. And we're going to rename this one to velocity. And this field condition can be friction. That's what it's supposed to be faking. Copy this condition. I guess I'll save this one again. C, D, E, F. Back into this one. And honestly, I think I'm going to turn off that first emitter. Yeah, so we get the second one. I'll move it down. And then paste. Drop this here to be another math. And we need our new point object, which is a new connect, don't weld, link that geometry to the new geometry. Collider, actually, yeah, it's friction geo. Cool. And save this one. All right, let's see what we get. Yeah, everything should be on. It's going to take a second for the gravity to take over on there. Kind of hoping for a little speed burst here. Come on, go, fall, go. You can do it. We don't want to crank it up too high because then you're going to like lose the bobbiness. And, you know, well, it's like it's been 2 seconds. So how much should have gone? Maybe more. Let's see. While that's slowly going, let me look at the chats. Sid asking, anyone have an idea of how to create a network of splines that don't intersect? Think of a maze of factory conveyor belts that overlap without intersecting. And then specifically, Sid is asking, would Ricochet be a good use for this? We're almost out of time. I want to finish seeing if this little frictiony thing works, which is not going to be super fast. But I might have a vague idea of something you do there, and depending on the scenario, Ricochet could somewhat help, but I think we'll use some simulation to make them avoid each other. Come on, go blob, go blob. You can blob. Do it. Turn green. Almost. Oh, this feels like they're colliding, but they're not turning green. Why aren't they turning green? Collide surface 7. Bigger. Interesting. Particle group. Friction. In the friction. Is that the right sphere? I think it's the right sphere. Boop, boop. Yeah, that's the right one. Why are you not changing color? Oh, wait, what? I know I copy and pasted from a different scene, but these are outputting to that particle group. And that's the group, and here's the field condition. And I'm saying no condition, just assign the color to this, and it's not changing color. Did I not start at like frame 0 so like it didn't initialize? What's going on here? That is weird. Like, it seems like maybe that could have been my fault. I might have been at frame 1 or something when I jumped in the scene, and then everything initializes at frame 0, or at least the earliest frame, so it wouldn't have acknowledged that new thing. Unfortunately, we just have to let it go again. I don't want to do that. It's taking too long. Because there's not much going on in the scene, and it's going slow. I don't understand. Anyway, I don't want to bore anybody with that. I mean, I do like the idea that we did here. This one is working marginally faster. Like, it's like, oh, you won't work for us friction? Fine, we'll make our own friction with math and fall offs. And in theory, that might give us a bit of a rolling behavior. Because even here, I think, like, yeah, those are moving very slowly, but the ones on top of them, you can see how that, like, any one particle is kind of hopping from one to the next one, the next one. So it's sort of rolling. And then once that one is the one that touches the surface, it suddenly slows down. And then the next one is going to start rolling over that. So I dig it. And I think that could and would and should work. I wonder, just here, if we made way fewer particles, not for speed, but to see if they sort of blob the way I want them to in these smaller blobs. Kind of oozing down, really stuck. And keep in mind, I didn't tell them to stop dead. I just said that they're losing a lot of their velocity. They're losing half their velocity. So gravity is still constantly working on them and constantly wanting to pull them down. Essentially, what I want to get a vibe for if, like, these top layers are more smoothly falling than the ones closer to the surface. Which is the way I think fluids would sort of work, but it's just not running quite fast enough for me to distinctly feel it. Okay, like, let's watch. Well, it's kind of too late, but like watching this green particle, like, kind of work its way, like, definitely past those. But now now it's too late to actually see if it was, if that's there. Although, like, maybe if we're going back to the original idea that this was supposed to be, which was like the olive oil, like, something that's kind of cool about the us at the friction, our version of friction kind of working is, like, these are moving so slowly on there and they get stuck, but then these other ones are still, the flocking is still like, no, but I want to hang out with you. So, like, this final drip is like, but I don't want to let go because I'm the final drop, like, I'm on the surface. But you see that the flocking is working to our advantage in both ways, where it yanked off the ones that were on the wall because they still wanted to hold. So it's like we're building in the properties of the thing we want. It's just not running fast enough for us to be able to do, to, like, test it quickly. But, like, even here, it's like, okay, here's a little blob. So it's like, is this blue one, is that little blue one going to kind of work its way all the way around until it becomes the very front of the train? And then hopefully it'd be like this back one gets peeled off. Yeah, right there. Look at this, that one that got peeled off the back. And then will it kind of make its way around? It might get churned through. I mean, I guess we're kind of falling off the side a little more quickly, but, like, generally speaking, I feel like the blobs are rolling. Like, look at this one right now. I distinctly kind of feel like there's a bit of a rolling motion going. Like, it's not fast, but I feel like it's there. So, like, when we build our own friction, I feel like we're actually getting a pretty good result there. I just need this to be running 10 times faster than the viewport. But I dig it. I dig it. Okay, sorry, very distracted. I mean, I'm interested because I was kind of working, but, like, we need to be able to iterate, and if it's taking us an hour to, like, test it and change one parameter and then run it again, like, it's no fun to take 5 minutes to test one simulation. So, question about the. Yeah. Okay. Well, Sid is asking about just drawing, like essentially a network of splines that are not intersecting. And honestly, we can just do simulation with this, which is really straightforward. And if you haven't seen kind of my The old school people here are going to be familiar with this demo, but I might as well do a slightly fancier version of it. Let's fill, like, let's say that these are conveyor belts, and it might be going overboard for you're looking for, but let's type out some text, and let's say that we're going to essentially want to fill these with spaghetti. So we want a bunch of lines that are not intersecting. I just want a nice beefy font. And let's not spread them out so much so they can barely be booping into each other. And we could do them rigid body, but just for nicer collisions, I will put them into a builder. And then we get this blobby mesh. And if we're getting fancy, we can say 5. And if we want to reduce, we can use remesh. Drop it down to 50%, 0 adaptability, very even poly count, nice and round all the way around. Cool. And then we use a ricochet. So yeah, my plugin ricochet. We can start this wherever we want. So I could just scoot this over. That should be inside. Yep. And I say, what are you colliding with? The object. The object will be the remesh. And now I can say hide the sources, which is just a button we have, and we have let this start bouncing around. So now ricochet, what do we want to do? Well, we have a total length, so we can keep on increasing that. That's bouncing around, doing its thing. Right now, it's got a lot of randomness that we can feed in, but I would kind of like some straight lines, so I might. Usually we are doing, trying to align it with the surface. I'm going to align it a little bit with the normal, so it's kind of straightening itself out a little bit, and then we can keep on letting it bounce around, so we just kind of get more lines. So let's type in some ones, type an extra one. Is that too many? I don't think it's too many. Now, I might want to kind of try something new. I'm a little worried about combining it, but like we've got the break spline modifier. Yeah, that might be a little slow, but let's just, I'm curious. Maybe I'll even crash. Ricochet. Don't intersect. Save. Okay, cool. So we can do that. Now, the simple version is I can say this is a collider body. So that's a collider. And, it's probably a good idea with Ricochet to not let these quite hit the wall. Now, luckily, there is a setting called Modify. And I can do a surface offset. And if we do it negative, then essentially I'm deflating it as far as Ricochet is concerned, a little bit smaller. So everything should be trapped inside. And you can show that here. You see these little dots are now in. They're a little bit more inside than they used to be. Okay, so now we say that this is colliding on the back side because it's going to be bouncing on the inside. And right click and say simulation. Actually, I probably want to remesh this or resample it. So I'm going to take the ricochet. I'm going to throw that into another rocket lasso tool called utility splines. I'm going to say resample. Yeah, let's do a resample. And then I'm going to say, yeah, it's currently set to step. So if I double click on it, you can see that it's subdivided everything. So it's like subdivision. Probably want some more. So I'm going to drop this down to 3. And yeah, so now, yeah, point. So yeah, a little bit more, few extra points there so we can actually run that with more detail. Double click it again so that we don't have to see the lines. And right click and add a rope. Hopefully rope is still working well for us. The radius is 0.5. I'm not sure if that's too much. I'll say 0.2 and hit play. And gravity's still on. Actually, okay. See, I love rope simulation. It's so good. Instantly, you see that we got all this like spaghetti just like flopping down. So now let's turn off gravity. Control D. Simulation. No, scene gravity 0. Okay. So now if I hit play, like right now, some of those lines are definitely going to be intersecting with each other. But as soon as I hit play, these are all going to be drifting around away from each other. And now we know for a fact that they are not intersecting up to a radius of 0.2. Let's say 0.5 and hit play again. And now they're bigger lines and they all kind of wiggling. It's a little bit hard to tell. But now if we were to take that and sweep inside radius of 0.5, none of these should be intersecting anymore. Like all of these lines have a radius of 0.5 saying don't intersect. So nice and clean, not intersecting. Now that we can actually visualize it, let's see how far I want to go. So definitely go up to 1. Keep in mind, volumes fill up quick. So now we're going to double it again to 1. and say go again, they're going to be fatter. It's going to, the first frame is going to take a little longer because there are more intersections, but now you see the whole thing is filling up real nice, spaghetti-like. And now you see that, well, actually, let me rewind. So you see at the beginning, like lines are just like crisscrossing, like passing right through each other. You let the simulation do its job just for a few frames, and suddenly everything settles in, a little friction, or you just let these do their thing. And I see they're not intersecting anymore. So, obviously this Ricochet made all these lines for us like really easily and quickly, but you could have, just filled this up with, you could have made scribbles carefully inside of it and all over the place, and made enough lines that eventually you could end up with something like this. Now, obviously, this was going overboard where I made like a ton of lines. So not exactly conveyor belts here, but we could turn gravity back on. Boop. And let's see, even with it the way it is, like these are going to fall, and in theory they're going to be colliding. And that's like, this is how much space we actually filled. You see, there's actually still a lot of air in there. So we could have had these, we could use 3 times as much spaghetti, or we could be having the radius be 3 times thicker than it currently is, and we'd still be right around the volume of it. So yeah, really fun technique to be able to do like lots of weird, wacky things with simulation, like really quick. Like all the Rocket Lasso tools pairs so well with the simulation stuff. Let's try doubling again. Why not? Radius of 2. And you never know if something's going to escape. Actually, yeah. So I doubled the radius, but like you double it and it's like super full now. So 2 is probably too much, but now you kind of get these brains kind of look going on. And then, if we were to shrink the radius, you'll actually get a little bit of space in between all of those. So the radius is still big for the simulation, but it's really thin for the pipes so they don't collide. And then it's kind of, I might as well just complete the demo because it's one of my favorite Ricochet demos. But, we ran this with like quite a few polygons. You can see that these lines have a lot of subdivisions. We could have gone higher. You see the simulation still runs really fast, but you can still end up with these kind of janky, sharp edges. Like that's really sharp. That's really sharp. So your solution, the solves there would maybe be really subdivided for the simulation, but the Rocket Lasso resampling tools, our utility splines, are really helpful here too. And remember that the simulation runs as a deformer. So these splines have deformed to this new position. But now I could take the end result of that position and I can feed that into a Rocket Smooth. And I'm going to say I want to subdivide. Let me change this. So you can see I'm now subdividing. We say 0. I'm going to subdivide. Oh, let's do that. So you see this is what it looks like. I'm going to say subdivide an extra time. So essentially I'm putting an extra point in between every existing point. And we still get these sharp edges. But as I add like 1 or 2 subdivisions, you see I got all these extra lines. And now let's override our point cap. And now I'm going to increase my smoothing by like 1 or 2 levels, just a little bit. And now we put more points in after the simulation and then subdivide it and then round it out those points. So we get rid of those sharp corners. And now we go back out. And now we got lovely spaghetti or brains or intestines going and no sharp corners anywhere. So yeah, really, really love that combination of things. So yeah, all these twisting around, doing their thing. Now you're talking about a conveyor belt. Like obviously this is a crazy scene, but even here, if I go to my end side and give it only 2 sides, this is going to turn into like this flat ribbon. Actually, I don't think I've ever done that. I've never just said like, oh, make it 2-dimensional. So we got all these like ribbons and, well, I guess in this case, conveyor belts, doing their thing, like just hanging out, never intersecting with each other because the simulation is doing that for us. And then potentially you could bake it down to alembic, or you could make this editable and bake it down so you get that final spline ready to go. You could imagine you could, make some sort of material on here that you could be, having a conveyor belt type texture, like traveling along, or even, this is, I'm not sure. I kind of want to push a little bit further because it's looking really nice. So let's simplify a bit. Let's go back to our simulation. I'll save that, and then I'll save another version. I want to simplify a bit, so let's just make the letter C for conveyor belt. And somehow the Ricochet, the Ricochet just coincidentally was still just barely inside it. Now it's 1/3 the letter, so let's make it 1/3 the length, or thereabouts. So Ricochet divided by 3.3, just a little bit less than that. So now if I hit play, that should do a pretty good job of, like, it's doing all the colliding and whatnot. It fills up the entire shape. And then actually I have always had a question, because that's doing the deformation, and now we smooth it out and get the ribbon. But because that's simulated, if I make this editable, do we get the end result? Maybe. It seems like we did. So here's the thing I like doing is I'm going to copy that end result, hit undo. And now I've got my old one. I can always go back to that. If I can turn it off and I hit paste and I brought back the one I just made manually. So we can always go back to that if need be. Also, that would be a really good use case for recall where we could bring that back again. So now we got this ribbon, very evenly distributed. And let's say you know, it's supposed to be, I know your conveyor belts probably were not supposed to be this crazy, but let's say that there's some products that are supposed to be going along it. So let's make a cloner, and the clone is going to cloner, or I'm sorry, the cloner is going to clone onto that path. Hopefully the direction will be the same as the sweep. I'm just not sure. Luckily, we've got a set count here. So I'm going to say multi-instance, make 1,000. And I'm going to make a little box. And let's set that to, I don't know, 222. What's the right size? Yeah, okay, that's not horrible. Maybe a little smaller, but we'll get there in a second. Make a sphere and set that to a radius of 1. Radius of 1. Oh yeah, there's a slight refresh issue in the cloner in multi-instance mode, where when you change a property, sometimes you have to turn it on and off again to trigger the full refresh. Anyway, those are clones, and then now I think I can offset these. I guess on Y in this case. So you see everything; those got pushed off, and now they're on the top. Let's grab what would be our conveyor belt and just say automatic. Make it kind of dark, not too dark, and then I'm going to say cloner, which just for fun, random, not actually no, not random. Plane effector, not random. Go to fields, make a random field. I like doing this way because now we can say random color, and now they don't blow out negative wise. So yeah, a bunch of little random color ones, and now go back to our cloner and say, give it some rate. I'm going to say 1%, which I just don't know what the speed is going to be. Yeah. Actually, maybe that does make sense. 0.001. Yeah. It actually does need a very, very, very tiny number because it's a very, 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 very long spline. So they were even if they're going 1% of the speed of the spline, it's still insanely far. So let's give ourselves more frames. And now, make these 10 times faster and turn on smooth rotation. So those can start traveling along. And now, maybe I'll even push it just a little bit further. We could maybe get fancier in several different ways, but let's say 1.1, so we're not passing through. And now we've got a bunch of items traveling along our conveyor belt, and it's even aligned because there's no rail spline. So essentially, they're following the same natural curve that the spline has. And you see all these items are actually just going to be traveling. Now, obviously, these items are kind of big, so they will bump into like other conveyor belts. But if we made essentially, if this world was like tinier, I'm gonna make the conveyor belts tinier, and then we make all of the items also tinier. Then now they shouldn't bump into anything. Now, now these will just all travel kind of seamlessly through the entire scene, just traveling these different lines, doing their thing. And then, like one more thing I gotta do now. Is this a good idea? Is it even gonna work? Okay, we save this. Yeah, it's a second version. Okay, let's make a camera. And I'm gonna make a null. The null is going to. It would be kind of nice if they were just linked automatically. No, I'll do it separate. So I'm gonna make a null, and I'm gonna say, okay, null, you are going to align to a spline, and the spline is going to be tangential, and it's going to be the baked down spline. And then you can see that that's going to be traveling along the entire thing. So I'm going to say, okay, at the time, let's turn off. This is going to be very important. Let's turn off our interpolation. So let's change our animation to be linear instead of spline. So it's just very simple. And now I'm going to say, okay, at the beginning of the animation, I'll start at 1% in. And then at the very end of this animation, I'm going to say 10%, which is probably way too fast. But actually, let's just hit play. And then where's my null? Yeah, so there's the null. Well, it's not too bad. We might end up slowing it down. It does seem like it's a little bit jittery, like it doesn't have that smooth spline thing going on. I might be able to solve that. But now let's put that camera in the null, reset the transform, link to the camera, and now physically move ourselves up a bit, and then hit play. And now we're riding that rail through the conveyor belts. Now you see we are getting this jitter going as it's trying to travel along. That smooth, you saw the checkbox I turned on with the cloner. Where was it? The smooth rotation. Honestly, I'm not even sure mathematically what that's doing on a technical level, but you see there is no equivalent on the spline. So I've got two potential options on that. First of all, let's slow ourselves down a little bit. Like, I don't mind it moving at a different speed of the packages, but I don't want it going so much that we're getting a little kind of seasick there. So about half the speed. And then we'll widen our angle a bit. And then, okay, I'm going to take the camera out. Actually, when the camera is here, that is the position. And I'm not sure. I'm going to zero that out. Okay, so this is essentially the offset we need, like 0.6. So if I hit Alt-G, there's now a null exactly where the camera was. So then I'm going to right-click on the camera and say animation. No, not animation. Rigging tags. And let's put a constraint tag on. And I'm going to say that the camera is going to have a transform. And the transform is going to say 100% the position of the camera is going to match to... I'll just say cam null. So it's linking to the cam null. Now that's also going to be rotating to match whatever that one's doing. So now if I hit play, the camera we're on is moving, but you see it's not rotating. So at least it's not like jittering. And actually, it's kind of cool to do that. But now I'm going to say a separate. I am going to make a separate one. It doesn't have to be separate. So first that one calculates, this one calculates after. But now this one, I'm going to say you're not transforming. Now you are springing. And what are you going to spring? Well, you're going to spring the rotation to match the camera null. And the length is 0. That's what I want. And then now we've got very important settings of drag and stiffness. But let's go to the beginning. And actually, it might be a little nauseating at the beginning, but let's hit play. And now you can see that the camera is got its own little springy lagginess going where it's like takes a little bit of time to catch up. So a couple things. If we make... Yeah, you see there's even some like jiggle going on there. Now it feels like we're twisted a little bit. Null. The null is at 0. This should... It's the rotation. Is it a relative rotation? Like there it is. Oh, yeah, Dean, you're right. We got to fix the clipping. So let's go into our Control or Command D, Project, View Clipping, and I'm going to say small, or you can even twirl it down and you get your near and your small. So I'll just say 0.1. So now there was like some clipping in the ground where like the lines were getting cut off. But you see, it feels like we're not tilting properly. Maybe we are. Maybe it's just taking a little bit to rotate to it. But it feels like we're sideways on it. Interesting. But yeah, more stiffness means it'll more quickly get to the position. More drag essentially means it's going to go slower, but effectively it means it's kind of a drag or a smooth on it. So I think we want relatively low stiffness, but relatively high drag. So there's not like a lot of jitter and the camera will rotate more slowly into position. And now you can see we're just traveling through the world of this conveyor belt. Working surprisingly well. Like it's pretty cool. And there's no, at this point, there's no simulation. So we could just jump to any time and be at like a different part in the animation. There's like, this is entirely essentially pre-baked. So we could find like a particularly fun part where it's like, oh, like it looks, let's say it looks really good right around here. So then you could be like, okay, well, start at that keyframe, end at that keyframe, trim it down to like only the first 100 keyframes. And that should just kind of work. Let's see, we can grab this original camera and like be a little bit more off the track. And then, yeah, we're free to grab this and okay, that's going to turn it left. But let's see. Okay, yeah, this is turning it down. I want to look down at the rail we're on a little bit more. And, it could go to, maybe maybe we don't want the extra geometry, but I could just duplicate that path that we're on, and I could subdivide it more. Potentially, we could even change this mode into like a B spline or something, and give it like a 1 degree type of thing. And now we just say, okay, rail, you're on a smoother spline, and that should also help give us a smoother ride. But I like the camera like lagging and kind of turning around. I could spend more time trying to figure out why we're not quite aligning in the orientation I thought we would. Um, Sometimes it kind of feels like it is, but yeah, definitely there we flip from one side to the other. But we are in a different spline now, so it might have a different rail. We might need to like make a rail, which we could do, but we are almost a half hour over. But yeah, hopefully that's kind of a fun thing. We could have keep in mind it's like I have the objects traveling like a conveyor belt, but you could also have a texture on there, and that texture could be offset as well. Yeah, I like how we kind of fly over the cubes now. But yeah, then we just made like the ultimate roller coaster, totally random, never intersecting, and just traveling around. So yeah, we never really did this before. So I really like it. Fun question. Sid at least seems happy with the answer. So I know we got off the rails as far as like what might be a more simple motion graphics conveyor belt system, but you don't get much kind of zanier than this. Running nice and smooth as well. Wee. Yeah, it might be better if this had minimized surface area and we're traveling in this big C shape, but it might have been better if this was in like in a sphere. A sphere has the most volume to the smallest amount of surface area. So that could go, that would mean we have more interior range that we're traveling. We could also, it's really fun building these types of camera rigs where I could have a camera that, generally speaking, is like trying to anticipate where it's going. So maybe there's a second null in front of us that's always kind of trying to look in that general direction. You could add additional jitter or wiggle on top of these, so it's like kind of like a little bit shaky as it's traveling around. We could have a secondary target that's kind of looking in the center of mass, trying to like find that area. So yeah, you can definitely always layer up like camera rigs. But yeah, I think this might need a rail spline. And making a rail spline wouldn't even be that hard. Because you could even make this type of geometry here and then make it editable and have like the top of the rail, like one side of this be like one rail and the other side be the upper part, or one would be spline, the other would be the rail, so like the up vector for it. So that's a good way of getting a rail spline in this type of situation. And yeah, rail splines are kind of a guarantee that things will work, even if they're like a pain to put together. And then I'm trying to I'm not going to do it, but I'm pretty sure in this rig, I mean, there's all things we do. We make this look like railroad tracks, like an entire rig. This could be like a railroad track system traveling through. Yeah, I wouldn't even mind revisiting this again next week, like just kind of tinkering around and making spending more time on it when we're not overtime already. But a crazy possible thing, it might even still run somewhat reasonably, but I think it might even be possible to do this and have it be a live simulation. Like the live spline could still be oozing around and traveling and actually moving as we go. Like that might actually work. Like this whole setup here is pretty clean. I don't see why it wouldn't work. Maybe it wouldn't, but I don't see why it wouldn't. Whee! Anyway, that's pretty cool. Thanks for the question. I thoroughly enjoyed it. Let's delink from the camera. And yep, there's our wacky roller coaster ride. I dig it. Anyway, thank you so much, everybody, for coming and hanging out. We had some excellent questions, even if Particles was not cooperating too much. It started cooperating a little bit better later, but maybe laptop video card, or maybe there's a something triggering stuff to slow down. I'm not sure. Zach, thanks for the radius too big. That was just totally derping on forgetting the radius. But I think that is going to wrap this up. Thank you so much, everybody, for coming and asking questions. If there's no questions, we wouldn't do a live stream. Thank you so much for the support and the donations. It is deeply appreciated. And of course, if you want to support Rocket Lasso, the absolute best way to do it is to either follow on Patreon or you could pick up one of these plugins, like pick up Ricochet or pick up Utility Splines. We actually just made a big spline bundle where you get like 30% off buying all of our splines as one go. So yeah, buying a tool that actually lets you do cool new superpowers inside of cinema is the best way of supporting us as well. But anyway, thank you so much, everybody, for coming and hanging out. That's going to wrap this one up, and I'll see you next week. Bye-bye.